So today we're not going to do problem of the day as we always do. We are rather going to improve ourselves so that we'll be able to do problem of the day questions when the time is ready. So come on, students, grab your pen and then take note of these things that will help you. Whenever we are given something like A all over B, we can express that as A times C all over B times C. And in this case, somebody will ask that why do we have to even do it like this? Because when you simplify it, this C will cancel this C, and then we are going to get A over B back. And more to realize, you should know that if you should multiply this by a different one like D, the base should also be the same as you should also multiply the base with the same number. Okay, so in this case, this can cancel that, and still we are going to get A all over B. An example is this. Whenever we are given something like, let's say 4 all over 3, we can express that as 4 times 2 all over 3 times 2. That is going to give us 8 all over 6, which is fine, but in a way, the simplification is somehow better. So examples like this can help you to go for this method. For instance, 4 all over 3 plus 5 all over 2, which is a simple example. You might be able to do it like this, which most of you normally use. You are going to do something like this, and then you find the LCM, which will give you 6 in this case. 3 times 2 will give you 6, and then 3 comes into this 6 how many times? 2 times, and then that 2 going to multiply the 4. You are going to get 8 plus 2 comes into 6 3 times. The 5 here is going to give you 15. That's going to give you 23 all over 6, right? This is fine. But you can also do it like this with this method. 4 all over 3 plus 5 over 2. In this case, we are going to take this 3 and then we will multiply it by the whole of this, the 5 and the 2. And then we are going to take this 2 and then we will multiply it by the whole of this. So let me apply it so that you get the concept. So we are going to take the 2, and in this case we have 4 over 3. So 4 times 2 all over 3 times 2, where this 2 is this one. And then we are going to bring our sign, which is the plus here. And then we are going to say 5 times which number, if you can see it over there, in this case, this 3. So 5 times this 3 all over 2 times the 3. And that is going to give us 4 times 2 is going to give us 8 all over this will turn 6. The 3 times 2. Then our plus will come. Then the 5 times the 3 is going to give us 15 all over 6. Whenever you're having something like this and the bases are the same, you just need to repeat the one of the base and then you can add the top. So in this case, 8 plus the 15 is going to give us 23 all over 6. The only key that you should have in mind is that whenever you're having A on B plus, let's say, C on B, you just need to repeat the B since the B is the same, and then it will become A plus B. That is that. Example is 2 all over 7 plus 5 all over 7. In this case, the 7, we have to repeat that. 2 plus 5 will give us 7, and this will even turn 1. Or should I say 2 all over 7 plus 9 all over 7. In this case, we just have to repeat the 7, and then this will turn 11. So 11 over 7. You see, this is very simple. Okay, so you don't need to find the LCM, then the 7. The bases are already the same. Just use that method and go your way. So whenever you have stuff like this, you just make sure that you make the bases the same, and then with that method, you can just go straight to the answer. So let's solve another example. Before that, I want to remind you that whenever you're having something like this, focus here. Whenever you're having something like A times C all over B times C, you just need to cancel this, and that will give you A over B. An example, in this case, let's say 16 all over 4. It can be expressed that 4 times 4 all over 1 times 4, where 4 times 4 is a 16, and then 1 times 4 gives us. So this can cancel that, and then we are going to get 4 over 1. That will give us 4. An example, per the one that we did here, that was 8 all over 6. And we can say, in this case, 4 times 2 all over 3 times 2. And that will give us, this will cancel that. We're going to get 4 over 3. And most of the times we just use our eyes to look at this and then we continue. We don't normally write it or expand it as we've expanded this. But these are the tricks that we use, especially with this one that we've just discovered. During NSMQ, most of them, they just do it, and within a short period of time, the quiz mistress will be given a very, very huge numbers and long numbers, and then within 30 seconds, somebody just rings the bell and then raise the hand and then respond. And you're like, how? These are some of the tricks that they use during NSMQ. We are not actually working on NSMQ, but during your commerce time, you might need something like this. Okay, so let's look at this example. So with this question over here, we can apply our concept. But first of all, we should look at board mass, where we have brackets of division, multiplication, addition, and then subtraction, as you were taught in the classroom or even in JHS. So you're going to consider the bracket first. So that means you have to repeat these numbers: 3 over 4 divided by 5 all over 4 times, and then within the bracket we have these numbers. So we are going to take the 3 here and then multiply it by the top and down. And in this case, I'm going to overlook. I'm going to overlook. Okay, so let me just expand it so that you can get it. So 3 times this 3 all over 2 times the 3 here minus this 2 times the 2 here all over 3 times the 2 here, like this. So we are going to get 3 over 4 divided by 5 all over 4 times the bracket. This is going to give me 9 over 6 minus this is going to give me 4 over 6. So from here we can say 6, and within this here and here, we are going to say 3 over 4 divided by 5 all over 4 times. So just use your mind to get it. Over here we can say 5 over 6. The reason is because we are going to repeat the 6 here. Then we are just going to make sure that this 9 minus the 4, that's going to give me 5 all over 6, right? So now we can be like 3 over 4 divided by 5 over 4 times 5 all over 6, right? So division next. So we are going to get 3 all over 4 times, we are going to reciprocate this though. So this time 4 all over 5 times 5 over 6, as it is shown in here. So from here we can just, this will take this 4 will take this 4, this 3 will come here 1, then come here 2 times. So per our method, there is only 1 here. So 1 here was 1, here 2 was 1. So 1 times 1 times 1 will give us 1 all over, here was 1, and then here 2 was 1. So 1 times 1 times 2 will give us 2. So our final answer is 1 all over 2. That is our final answer. So we were able to apply that method that we learned earlier in solving this problem. And in situations where you have a very, very long problem, a huge problem, you need to use this, and you can use this more than 1 time, sometimes 3 times, 4 times, 5 times, and not all the time that you're going to find the base and then you're going to do something like this, and then from here you're going to be like this comes here, and then that is leave that to the JHS people. Okay, so this is fine. Let's look at another thing. Whenever you are given something like A all over B times C all over D, we all know that it will become A C all over B D. It doesn't mean that when you have something like 3 all over 2 times 5 all over 7, it's going to give you 35 all over 27. No, this doesn't really make sense. In other words, we are only combining these things because they are letters. But for numbers, you just need to use your multiplication indeed. So 3 times 5 is going to give us 15, and then 2 times 7 is going to give us 14. So this is not how we are going to do it. This is how we do it rather. But in a way, when you have something like A over B times C over D, and then we can express A over B. In this case, the C, we can express the C in the form of D. We can express the C in the form of B. So something like, let's say BE. Notice that the C is now BE. And I'll give you an example so that you get it. All over D. This B will cancel this. And then now we are going to get AE all over D. An example is this one. We might have numbers like, let's say 4 all over 5 times 15 all over 7. Okay, so in this case, we can express this as 4 all over 5 times 3 times 5 all over 7, where this 5 is going to cancel this 5. And then now we have 4 times 3, that will give us 12 all over 7. A much more complicated problem can be in the form of, let's say, 8 all over 2 times 9 all over, let's say, 4, okay, and maybe times 1 all over 3. Okay, so in this case, let's simplify it. This 2 can come here and then we'll get 4, okay, and then this 4, or let me just follow the procedure indeed. We can express the 8 as 4 by 2 all over 2, and then the 9 we can express it by 3, okay, and then the 4 can be as 4 here, and then times 1 all over 3. So I've just written this in this particular form, okay. So this 2 can take off this 2. And you can see that this 4 can take off this 4. So the 2 came here 1, here was 1, 4 came here 1, so 1. So 1 times 1 is the same as 1. So this 3 2 can take off this 3. So now we have 1 here and then 1 here. So now when we simplify this, 1, the whole of this was 1 times 3 times 1 will give us 3, okay, and then 1 times 1 times 1 will give us 1. So our final result is indeed 3, okay. So this is something that you can use whenever you are doing simple simplifications, okay. Whenever you are given something like A all over B divided by C all over D, we can say, or we normally say, A over B times what? Do you remember? That is D all over C, right? There is no situation that will accept the fact that this time you are going to reciprocate this. In fact, we reciprocated this. If I should say it in tree, yet anyway, no upside down, and I say you butu way, so I've actually used English throughout, and now that I'm coming to use tree, okay, no problem. So C all over D is now D all over C. That is called reciprocation, okay. So you should never reciprocate this, the first fraction, such that is now going to be B all over A times C all over D. That is going to give you a different answer. In fact, this one is going to give us AD all over BC. And then this one is going to give us BC all over AD. So this is going to reciprocate this. It will invert this. So when you rather reciprocate the first fraction, you're going to get the inverse of the main result that we want. Unless after getting it, then you reverse it back, where it doesn't make sense. So you just need to reciprocate the second one, okay, in a more trivial way. Maths, those kind of stuff, maybe you intentionally go and reciprocate A over B, and then with that you just want to prove to your teacher that I think there's no way you want to. You're just going to be like this, and then you just want to trick your teacher that you're a brilliant student, so something like this. And then afterwards, BD all over AC, and you intentionally find the inverse of it. And then with that, you are going to get your AC all over BD back. So let me give you examples so that you get it clearly. So in this case, when we have something like, let's say 3 all over 2 divided by, let's say, 5 all over 7, what we are supposed to do right now is that we are going to say 3 over 2 times 7 all over 5, right? And then with that, we can say 21 all over 10. So somebody is going to be like, this time 2 over 3. Notice that I have rather reciprocated this times 5 all over 7. I have repeated this as it is, and in this case, we are going to get 10 all over 21. And then with that one, you would turn it back to something like this, which to me doesn't really make sense. So don't do that. But in a way, some of you are still confused about either using reciprocating the second fraction or the third fraction, especially when you have a very much complicated stuff to work with. So I actually want you to battle with yourself with something like this. Let me just open your brain more with this question. I'm not going to solve it here, but you yourself, if you're really serious with your education, just do it on your own. Something like A all over B divided by C all over D divided by E all over F. So we have something like this, which is a little bit complicated. And if you get the answer for this, you can advance it by adding one more divided by G all over H, and see how you are going to get battles with this. This looks a little bit simple, but just struggle with it for a while. I wish to know how you struggled with it in the group. Thank you. So with this, you should note stuff like this. This is what I want to teach you today. This is something small for the Form 1s, okay? We'll be solving much more complicated stuff, examples like this, as time moves on. But for now, thank you very much for watching this whole video. It's a little bit long, but it's very, very helpful. Kindly go to our YouTube channel, and then over there we have similar videos over there. Watch more of the videos over there. We've solved a series of past questions over there, and some of them is what I show here. So go and check the main channel, and then over there observe all the videos. Kindly like and subscribe to the channel so that whenever we send new videos over there, you would be the first person to see the video. So thank you very much. Happy New Year.